Science test, 35 minutes and 40 questions. Directions. There are 6 passages in this test, each accompanied by several questions. Use the data in the passage, charts, and figures to choose the best answer to each question presented. Then mark the corresponding oval on your answer sheet. You may look back at the passages while answering questions. You may not use a calculator on this portion of the test. Passage 1. Glycine max soybean is a species of legume native to East Asia. G. max usually undergoes self-pollination. Egg and pollen are from the same G. max plant, but it is believed cross-pollination, pollen and egg are from different G. max plants, could increase soybean yield. A study was conducted to examine the results of several pollination methods on bean yield and bean mass in a G. max population. Study. Before pollination could occur, 240 G. max flowering plants were selected and separated into 3 equal groups, groups 1 to 3. The groups of G. max plants were then isolated from each other and placed into pollination cages to protect them from insects. Each group was exposed to a different pollination method, see Table 1, the percent of plants that produced beans and the average mass per bean for each group, and determined 4 weeks after the pollination. See Figures 1 and 2, respectively. Question 1. What was the total mass of the beans produced by the Group 1 plants? A. 26 milligrams. B. 168 milligrams. C. 177 milligrams. Or D. Cannot be determined from the given information. 2. How did the pollination method from Group 2 differ from that of Group 3? The pollen each Group 2 plant received was F. Delivered by honeybee pollinators, whereas the pollen received by each Group 3 plant was delivered by wild bees. G. Delivered by honeybee pollinators, whereas the pollen received by each Group 3 plant was from the same plant only. H. Delivered by wild bee pollinators, whereas the pollen received by each Group 3 plant was delivered by honeybees. Or J. Delivered by wild bee pollinators, whereas the pollen received by each Group 3 plant was from the same plant only. Question 3. The groups were most likely isolated from each other in order to ensure that the plants A. would be pollinated by multiple pollinators, B. would not be pollinated by multiple pollinators, C. would self-pollinate spontaneously, or D. would not self-pollinate spontaneously. Question 4. The information shown in Figure 2 was most likely determined for each group using which of the following expressions? F. Total number of plants over number of beans. G. Number of beans over total number of plants. H. Total bean mass over number of beans. Or J. Number of beans over total bean mass. Question 5. The information shown in Figure 2 was most likely determined by data collected using which of the following pieces of equipment? A. Barometer. B. Voltmeter. C. Ruler. Or D. Scale. Question 6. Do the results of the study indicate that the type of pollinator has an effect on G. max bean yield? F. Yes, Group 1 has a lower percent of plants that produce beans and a lower mass per bean than Group 3. G. Yes, Group 3 had the lowest percent of plants that produce beans and the lowest average mass per bean. H. No, Group 1 had a lower percent of plants that produce beans and a lower average mass per bean than Group 3. Or J. No, Group 3 had the lowest percent of plants that produce beans and the lowest average mass per bean. Question 7. Which of the following questions about G-max does the study attempt to answer? A. Do the plants undergo cross-pollination or self-pollination in their native habitat in East Asia? B. Are wild bees and honeybees natively found in GMAX plant habitats? C. Does the presence of pollinators cause a difference in the average mass per bean and the percent of plants that produce beans? Or D. What is the length of time until GMAX plants produce beans after pollination has occurred? Passage 2. Bacteria found in farmland soil generates gases when they break down organic matter. CO2 is generated by aerobic bacteria, which requires O2 and CH4. It is generated by anaerobic bacteria, which requires little or no O2. Study. Surface oil was taken from 6 U.S. locations during the 6-month growing season of April through September to evaluate the long-term effects of tillage on aerobic and anaerobic populations of bacteria and microbes. Bulk density of these microbes were measured using an in situ, on-site technique. Soil samples were extracted using 25 millimeter cores. The soil was then passed through a 5 millimeter stainless steel sieve. Samples, which included large amounts of sands and pebbles, were passed through an additional 2 millimeter sieve. The samples were then evaluated. The test measured soil that had not been tilled against soil that had been surface plowed. Readings were measured on soil sections that taken at depths between 0 to 75 millimeters, 75 to 150 millimeters, and 150 to 225 millimeters of soil tilled using surface plow methods. The process was repeated on sections of soil that had not been tilled. The soil samples were then irrigated for 15 milliliters of water to measure their suitability for farming. Figure 1 shows that aerobic and anaerobic microbe density measured in terms of average distance to the nearest neighbor of the soil samples that were not tilled. Figure 2 shows the aerobic and anaerobic microbe density measured in the terms of average distance to the nearest neighbor of the soil samples that were plowed. Question 8. One reason that a portion of the soil samples was sifted through an additional sieve was to F. Minimize the amount of atmospheric gas contained in the samples. G. Prevent the bacteria from escaping the sample. H. Concentrate the amount of sand in the final samples. Or J. Remove excess sand and pebbles from the samples. Question 9. Based on the average distance to the nearest neighbor of anaerobic bacteria in the plowed soil at a depth of 0 to 75 millimeters, the average distance to the nearest neighbor of anaerobic bacteria at a depth of 25 millimeters would be closest to which of the following? Note, at a soil depth of 0 to 75, there is a linear relationship between average distance to nearest neighbor and soil depth. A. 8. B. 13. C. 17. Or D. 20. Question 10. The results of the study showed that as the surface depth of the no-till soil section and the plowed soil section steadily increased, the average distance to the nearest neighbor for both aerobic and anaerobic bacteria, F. Aerobic decreased while anaerobic increased. G. Aerobic decreased while anaerobic decreased. H. Aerobic increased while anaerobic decreased. Or aerobic increased and anaerobic increased. Question 11. The scientists who performed the study most likely chose to evaluate the 6 different sites during the growing season instead of during off-season because A. In the growing season there is more aerobic bacterial activity, only, and in the off season more anaerobic bacterial only. B, in the growing season there's more anaerobic bacterial activity only, and in the off season more aerobic bacterial activity only. C, both aerobic and anaerobic bacteria have more activity in the growing season than in the off season. Or D, both aerobic and anaerobic bacteria have less activity in the growing season than in the off season. Question 12. Based on the study, was CO2 gas emitted from plowed and no-till soil sections taken at a depth of 150 to 225 millimeters? F, yes, aerobic bacteria were present. G, yes, anaerobic bacteria were present. H, no, aerobic bacteria were present. Or J, no, anaerobic bacteria were present. Question 13. Each of the depths investigated has a different level of farming potential that is supported by the closeness of the bacteria to each other. Does the study suggest that the growth potential for no-till soil is higher at a 0 to 75 millimeter or 150 to 225 millimeter? And does the study suggest that the growth potential for plowed soil is higher in 0 to 75 millimeter or 150 to 225 millimeter? A, the higher farming potential for no-till soil would be 150 to 225, while the higher farming potential for plowed soil would be 150 to 225. B, the higher farming potential for no-till soil is 150 to 225, while the higher farming potential for plowed soil is 0 to 75. C, the higher farming potential for no-till soil is 0 to 75, while the higher farming potential for plowed soil is 150 to 225. Or D, the higher farming potential for no-till soil is 0 to 75, while the higher farming potential for plowed soil is 0 to 75 as well. Question 14. The study used 25 millimeter cores for all samples in order to make sure the samples would be accurate regarding which of the following measurements: F, percent volume of sand. G, the weight of the soil. H, the density of the bacteria. Or J, the weight of the wildlife. The population of the wildlife. Passage 3. To understand the effects of torque or twisting force, a group of students conducted 3 studies on the force exerted by several cabinets on their hinges during their physics class. Each cabinet had a unique mass, m, and the length, l. 2 hinges were affixed to each cabinet so that the distance, d, between them could be varied. The cabinets were otherwise similar. The hinges were placed on the cabinet so that they were an equal distance from the cabinet's center of mass. See the diagram below. The force on each hinge was measured using 2 force sensors. One sensor detected the vertical force exerted upon the hinge, F, V, and the second sensor detected the horizontal force exerted on the hinge, FH. After determining FV and FH for the individual hinges, the students then calculated the average for the vertical forces, FV average, and the average for the horizontal forces, FH average. Then average net force per hinge, F net force average, was then determined from FV average and FH average. For each study, lengths were recorded in centimeters, masses in kilograms, and forces were recorded in newtons. Study 1. The students found that F vertical average and F horizontal average for a cabinet with a fixed mass of 27 kilograms and a fixed length of 75 centimeters with varied values for D. Figure 1 displays the results. Study 2. The students found F net force average for 3 cabinets for various values of D. The cabinets had a fixed mass of 27 kilograms, but different values of length were used for each cabinet. Figure 2 displays the results. Study 3. The students found F net force average for 3 cabinets with various values of D. The cabinets had a fixed length of 75 centimeters, but different values of M were used for each cabinet. Figure 3 displays the results. Question 15. The cabinet with the greatest mass was tested in which of the following studies? A. Study 1. B. Study 2. C. Study 3. Or D. None of the studies. The cabinets in all 3 studies had the same weight. Question 16. How did Study 2 differ from Study 3 with regard to mass and length? In Study 2, M was varied while length was held constant, whereas in Study 3, mass was held constant while length was varied. G. Mass was held constant while length was varied, whereas in Study 3, mass was varied while length was held constant. Question H. Both in mass and length were varied, whereas in Study 3, both mass and length were held constant. Or J. Both mass and length were held constant, whereas in Study 3, both mass and length were varied. Question 17. In Study 2, had the students test a cabinet with mass 27 kilograms, length 120 centimeters, and D 70 centimeters, the F net force average would most likely have measured A. Less than 120 newtons. B. Between 120 and 160 newtons. C. Between 160 and 200 newtons. Or D. Greater than 200 newtons. For Study 1, when D was more than 70 centimeters, was vertical average greater than horizontal average or less than F horizontal average? And when D was less than 70 centimeters, was F vertical average greater than F horizontal average or less than F horizontal average? F. At D greater than 70 centimeters, it was greater. At D less than 70 centimeters, it was greater. G. At D greater than 70 centimeters, it was greater. At D less than 70 centimeters, it was less. At D greater than 70 centimeters, it was less. At D less than 70 centimeters, it was greater. J. At D greater than 70 centimeters, it was less. At D less than 70 centimeters, it was less. Question 19. Which of the following combinations of mass, length, and depth would produce the greatest force net average based on studies 2 and 3? A. 23 mass, 75 length, or 60 D. B. 23 mass, 75 length, and 110 D. C. 27 mass, 90 length, or 60 depth. Or D. Mass of 27, 90 length, and 110 depth. 20. According to the results of Study 1, which average force, F vertical average or F horizontal average, was independent of D? F vertical average, because as D increased, F vertical average remained constant. G, F vertical average because as D increased, F vertical average decreased. H, F horizontal average because as D increased, F of horizontal average remained constant. Or J, F horizontal average because as D increased, F horizontal average decreased. 21. An engineer has discovered that a flaw in the design of the hinges causes them to break when each hinge in a pair are exposed to a force greater than 250 newtons. According to the results in Study 3, the hinges will most likely break if they are not attached to a cabinet with a length of 75 centimeters that has which of the following combinations of mass and depth? A, 27 mass and 60 depth. B, 27 mass and 110 depth. Or C, 34 mass and 60 depth. Or D, 34 mass and 110 depth. Passage 4. The three categories of elementary particles that make up all matter are quarks, leptons, and bosons. Quarks, which bind together in triplets to form baryons, are a basic component of all atoms. Quarks bound to each other. Quarks have a mass greater than the sum of each quark's individual mass. Quarks, like all the elementary particles, possess the intrinsic property of spin. The spin of a quark can be oriented either up or down. Table 1 provides the generation symbol, electric charge, and strangeness of each quark. Table 2 lists the symbol, quark composition, spin, and approximate mass for 8 baryons. For which generation, if any, is the statement negatively charged quarks have the same strangeness as positively charged quarks? Not true. F, first generation only. G, second generation only. H, second and third generations only. Or J, none of the generations. The statement is true for all the given generations. Question 23. According to tables 1 and 2, a baryon with the quark composition DDS has the same electric charge as which baryon? A, sigma plus. B, charmed lambda. C, cascade B. Or D, proton. 24. All elementary particles have a spin of s over 2, where s is an integer. A quark with up spin has an s value of 1, while a quark with down spin has an s value of -1. Since a baryon spin is the sum of its constituent quark spin, what are the spins of delta plus and omega negative baryons given in table 2? F, delta plus is -1/2, and while omega negative is -1/2. G, delta plus is +1/2, while omega negative is +1/2. H, delta plus is -1/2, while omega negative is -3/2. J, delta plus is +3/2, while omega negative is +3/2. Question 25. Which of the following diagrams depicts the quark content and spins for an electrically positive baryon with only 2 quark spins sharing the same orientation? A's diagram, B's diagram, C's diagram, or D's diagram? 26. Does the information provided in tables 1 and 2 coincide with the known electric charge for the neutron? F, yes, because tables 1 and 2 indicate an electric charge of +1 for the neutron. G, yes, because tables 1 and 2 indicate an electric charge of 0 for the neutron. H, no, because tables 1 and 2 indicate an electric charge of +1 for the neutron. Or J, no, because tables 1 and 2 indicate an electric charge of 0 for the neutron. Question 27. Based on tables 1 and 2, atomic nuclei are composed of which generation of quarks? A, first generation only. B, second generation only. C, third generation only. Or D, first and second generations only. Passage 5. The figure below provides a pedigree describing the inheritance of dimples, trait Z, in a lineage. Assume that the presence of trait Z in a mammal species is determined entirely by gene Z. This gene has two alleles. Allele Z is dominant and allele Z is recessive. Each subject represented in the figure below has been assigned a letter, indicated below the symbol representing each individual for reference. Scientists have determined that the gene Z genotype of subject Q is ZZ and the subject O has genotype ZZ. Based on the information described in the pedigree, the scientists have determined the dimples, trait Z, are a dominant trait. Question 28. Based on the figure of the great-grandchildren of subjects A and B, how many, if any, have dimples? F, 0, G, 1, H, 5, or J, 6. According to the figure, which of the following two subjects are the most likely to have the most similar genetic makeup among their genomes? A, subjects K and L. B, subjects K and U. C, subjects L and M. Or D, subjects O and S. Question 30. What is the total number of generations that appear in the figure? F, 4, G, 5, H, 20, or J, 22. According to the figure, if subjects N and 0 have 3 offspring subsequent to the recording of the pedigree, how many of these children, if any, will have trait Z? A, 0, B, 1, C, 2, or D, 3. According to the information provided, will a subject with the gene Z genotype ZZ have dimples? F, no, because Z is a recessive trait. G, no, because trait Z is a dominant trait. H, yes, because trait Z is a recessive trait. Or J, yes, because trait Z is a dominant trait. Question 33. Based on the figure, does subject D have genotype ZZ? A, yes, because not all because not all offspring of subject D have trait Z. B, yes, because all offspring of subject D have trait C. No, because not all offspring of subject D have trait Z. Or D, no, because all offspring of subject D have trait Z. Passage 6. A chemistry teacher prepared a series of 50 milliliter solutions for her class using graduated cylinders. Solution A contained H2O2. Solution B contained a mixture of KiO3 and sulfuric acid. And solution C contained a soluble starch mixed with deionized water and diluted malonic acid. She then set a 250 milliliter glass beaker onto a magnetic stir plate fitted with a stir bar. See figure. Solution A was added to the beaker, followed immediately by solution B. The two solutions were then allowed to mix thoroughly before solution C was poured into the resulting mixture. The final mixture was left to stir for 30 seconds until bubbles appeared. The color of the solution proceeded to oscillate from yellow to blue to colorless for 10 minutes. When the solution finished oscillating, it returned to a colorless state. Student 1. During the reaction, the H2O2 in solution A reacted with a portion of the sulfuric acid in solution B, which in turn reacted with the malonic acid in solution C. This started a chain reaction that first produced a yellow solution of excess ice second, followed by a dark blue solution of excess pentyonide, and returned to a colorless solution. This pattern repeated until I2 was fully consumed. As a result, the mixture had no I2 remaining. Student 2. During the reaction, the H2O2 in solution A reacted with a portion of KiO3 in solution B, which in turn reacted with the malonic acid in solution C. This started a chain reaction that first followed a yellow solution of excess I2, followed by a dark blue solution of excess pentyonide, and returned to a colorless solution. This pattern repeated until the malonic acid was fully consumed. As a result, the mixture had no malonic acid remaining. Student 3. Student 2 is correct except that 1. The H2O2 fully consumed by the KiO3 in solution B, and 2. The reaction is limited by either malonic acid or iodate, IO3. Once either malonic acid or iodate had been fully consumed, the solution returned to a colorless state. Student 4. During the reaction, the H2O2 in solution A reacted with all of the KiO3 in solution B, which in turn reacted with the starch in solution C. This started a chain reaction that first produced a yellow solution of excess sulfuric acid, followed by a dark blue solution of excess malonic acid, and returned to a colorless solution. This pattern repeated until the sulfuric acid was fully consumed. As a result, the mixture had no sulfuric acid remaining. Question 34. A glass beaker was most likely used to mix the solution because a glass beaker has which of the following properties? 1. High reaction visibility. 2. Simple measuring system. Or 3. High impact resistance. F. 1 only. G. 1 and 2 only. H. 2 and 3 only. Or J. 1, 2, and 3. According to student 3's explanation, which of the following was responsible for the yellow color in the reaction? A. Pentyonide. B. Malonic acid. C. I2. Or D. KiO3. Question 36. Solution A also contained 35 milliliters of deionized water. This explanation of which of the following students, if any, is strengthened by this information? F. Students 1 and 3 only. G. Students 2 and 4 only. H. All of the students. Or J. None of the students. Question 37. According to student 4's explanation, did the percent of KiO3 by volume in the mixture increase or decrease during the demonstration? And did the percent sulfuric acid by volume in the mixture increase or decrease? A. Percent KiO3 by volume decreased and percent sulfuric acid by volume decreased. Or B. Percent KiO3 by volume decreased while percent sulfuric acid by volume increased. C. Percent KiO by volume increased while percent sulfuric acid by volume increased. Or D. Percent KiO3 by volume increased while percent sulfuric acid by volume decreased. Question 38. Which of the following students, if any, would most likely agree that the dark blue color in the reaction was caused by excess pentadiide. F, students 1 and 3 only. G, students 1, 2, and 3 only. H, all of the students. Or J, none of the students. 39. The final yield from a chemical reaction is constrained by the limiting reagent, the reagent that is completely consumed by the reaction. Which student would most likely agree that the limiting reagent during the reaction was the sulfuric acid found in solution B? A, student 1. B, student 2. C, student 3. Or D, student 4. Question 40. Which of the students would most likely agree that by the end of the experiment it is possible that there is no malonic acid remaining? F, student 1 and 2 only. G, students 2 and 3 only. H, students 1, 2, and 3 only. Or J, students 2, 3, and 4 only. End of test 4. Stop. Do not return to any other test.